What's up, guys? Welcome to my YouTube channel. This is my first video ever, and I've started a YouTube channel talking about blockchain, cryptocurrency, and everything in between. I've followed this technology for the last 6-7 years. I studied it in college, and now I'm lucky enough to work in the industry doing development, writing papers, conducting research, all that good stuff. And I wanted to share the things that I've learned with you because I know blockchain is all over the place. It's all over the news, and everybody that I talk to, whether it be in Ubers or walking down the street, meeting clients, whatever else, they always ask me what blockchain is, and I love talking about it, so I just want to share it with you guys. The first thing I wanted to say is feel free to check out my website. It is hashoshi.com. That's HASHOSHI.com. I'm going to be posting blog posts there every week, and I will accompany those blog posts with videos for those of you who are visual learners like I am. So that being said, welcome to the channel. Don't forget to subscribe. I will put a link to my website in this video. But thank you guys, and please do let me know what you're interested in learning about, because I want to tailor it to the people who are going to be here and following these videos and really wanting to learn. So I'd love to interact with you guys. Feel free to leave a comment, subscribe, and head over to my website and check it out. Cheers. So what is blockchain? Blockchain really at its core is defined as a peer-to-peer digital series of immutable transactions. And all those transactions are bundled up into blocks. And each of those blocks are time-stamped and appended to the previous one. So you get this never-ending chain of blocks, there in the name blockchain. These individual transactions are created by what are called nodes. And these nodes are represented by computers, and obviously people own computers. So you can be a node on the network yourself by connecting your computer to the blockchain and running the blockchain's code on your computer. There are 4 really crucial things that I've outlined in my first blog post, but I'm going to discuss here, that make blockchain truly special and that make it such a disruptive technology. So I'm going to go over those right now. The first one of those is that blockchain transactions are immutable. That means that once they're created and they're verified and signed into blocks, they can't be edited or deleted. So from an auditability perspective, this is huge. Having transactions that can't be deleted or modified, it closes the doors for fraud. It closes the doors for money laundering transactions that are open and viewable by any auditing agency. Beyond that, the blockchain inherently stores the entire history of transactions that are created. And the reason why this is important is because, like we said, to form an auditable record of all transactions, you need A, the transactions to be unmodifiable so you can trust them, and B, you need them to exist so that you can see them later on in time. So the entire history of all the transactions that have ever been created on the Ethereum network, the Bitcoin network, they're all still there. You can go online right now and look at the very first transaction that was ever created way back in 2009 for Bitcoin and later on for Ethereum. So third, transactions are peer-to-peer, meaning that if I want to transfer money to my friend in London, I send the money directly to him instead of going through a bank, then to another bank, then to him. And the real impact of this is, A, it takes so much less time. Right now, I have to send money, I have to pay a fee, I have to wait days for people, actual people, to verify that transaction, send that money over to a bank overseas, they do paperwork, and then they give it to my friend, right? With blockchain, those transactions happen on a near instant basis, and they occur for a low fee with no intermediary. So you're going to hear the word disintermediation quite a bit in my talks about blockchain. And really, that's one of the biggest powers of blockchain, is to take an intermediary out of a process. So in this case, for payments, you're taking the bank out of the equation because these transactions are happening peer-to-peer. And rather than having the bank do all of the work, you have special nodes on the network called miners doing the work. We'll talk more about mining in the next video, but that's a process called consensus, and that's what verifies these transactions. So finally, on the blockchain, each node on the network keeps a full record, or at least enough of a record of the blockchain such that they can A, keep up with the blockchain and issue transactions relative to the current state of the network, meaning they have the latest transactions, therefore they know the latest balances. But why that's important is that if my node disappears or it goes off the network or my computer blows up, which has happened before, my node, when it comes back online, when I boot it back up again, another node will pass me all the information that I was missing when my computer blew up or whatever happened. And what this creates is a fault-tolerant atmosphere. So if a bunch of nodes go down, the whole network can still run without those nodes, and when they come back up, the other nodes will fill them in on what they missed. So fault tolerance is another thing that's huge, and keeping a full record of transactions is a key part of that. Like many of the other technology innovations that have occurred in the last several decades, blockchain is built upon technologies and concepts that have existed for a long period of time. So the first one of those is peer-to-peer networking. So peer-to-peer networking has existed since the 90s, and if any of you guys remember Napster and some of those other file sharing, music sharing services, that's one of the first instances of mass adoption of peer-to-peer file sharing services. Blockchain's taken that concept where your computer is both the client, meaning the person gathering the information, and the server, so the person serving the information to other people. And in this way, it allowed individuals to share files with one another directly without having to go from their computer to a server and then to another person's computer. So you can see the parallel between that example and the one that we talked about with banking. Instead of the money going from my bank account to a partner bank, and then another partner bank, and then to the person it was supposed to go to, it happens directly. So you're disintermediating that process. So peer-to-peer networking is one of the key concepts upon which blockchain was built. So that being said, instead of files being shared, instead you're transferring value or a representation of value. So a Bitcoin, like everyone is always saying, really is not a physical object. It's not backed by anything, but it represents value because of supply and demand. But a Bitcoin could represent anything. The address that a Bitcoin is, it's just a piece of code, can represent anything. I could represent my glasses on the blockchain, send them to someone, and that would be a digital transaction of my glasses from me to them directly without an intermediary like eBay. So that being said, peer-to-peer networking is crucial to blockchain. The next thing is proof of work. Proof of work, I know for those of you who are familiar with consensus, know that proof of work is one of the names of the consensus mechanisms that we talked about before. I will go more in depth about consensus in my next video, I promise. In this case, I just want to introduce the concept of proof of work. All proof of work is a mathematical construct that's been around really since the 1970s from a cryptographer in Britain. And the concept of proof of work is that it's a piece of data that is extremely difficult or costly to attain, to get, but is extremely easy to verify. So think of it like a math problem in class. When you just get the question or you just get the answer separately, it's really difficult to track back and figure out what parts you're missing. Very difficult. But when you have both pieces, it's very easy to verify that those pieces fit together. It's plug and play. That is a crucial concept in consensus for blockchain. So remember the idea of proof of work. Really difficult and costly to attain, really easy to verify. So next, public key cryptography. This is something that's existed also for quite a while. It came around in the 90s into mass adoption. I think it's been around longer than that, at least the concept of it. But really what it is it's called asymmetric encryption, meaning that you have two keys that are mathematically linked to one another. And really they're derived from an extremely large and arbitrary number. And what this means is that you have a public key that can be shared out in the open. So anyone can see my public key, and that's used to encrypt information. And then there's a paired private key that I have to keep super safe, because those are the keys to the castle, if you will. That private key is the only thing that can decrypt the information that someone encrypted with my public key. And the same concept applies in blockchain. That public key is what's used as the address to send a transaction to, and the only person then who has access to that transaction and the information therein is the person with that private key. So keep that in mind as we go forward. Key pairs are going to be a very important concept in our next video. And then finally, this is one of my favorite ones, and it's not even technology related per se, but game theory. Game theory is one of the most crucial parts of blockchain. Game theory really, it's a study that breaks down human behavior when faced with a logical decision-making opportunity or faced with some sort of conflict or opportunity for cooperation. So if you think about it in terms of economy, the study of supply and demand relies heavily on game theory. You have to determine how someone's going to react to an increase in supply. You have to understand how someone will react to a decrease in supply. So the idea that demand increases as supply decreases is a crucial game theory concept. So if you think about it in terms of blockchain, without intermediaries that are paid to do the work of verifying transactions or overseeing the transaction of goods, you need some sort of incentive structure to incentivize other individuals on the network to do that work, and you need to disincentivize people from trying to cheat the system. So game theory is huge. It's probably the most important part of blockchain, and the whole system would crumble without an understanding of how human beings are going to react to different constructs and rules. So as we go into the next video, keep the idea of game theory in mind, and if you need to, look it up. There's all sorts of amazing content out there about game theory and the different uses for it. It is very common in economics, it's very common in humanities of all kinds, so definitely check that out. Beyond that, in the next video, I'm going to talk about, in a deep sense, how blockchain works, how the protocol works, how transactions are created, what those miners are, what consensus is. I know I've talked about that several times already. I will demystify that whole process for you. Until then, I'll see you guys later, and let me know if you have questions, and don't forget to subscribe. So, why should I care about blockchain? It's something that you might be asking yourself right now. The first thing that I would say to that is, it's not going anywhere. It's one of these technologies that's here. There are haters. There are people who don't think it is as disruptive as it is. But newsflash to those people who don't think it's going to stick around, it will. I am 99% sure that within the next 5 years, most of the applications that we are interacting with on a day-to-day basis will have a blockchain component. Beyond that, I think maybe closer to 10 years from now, everything is going to have a blockchain component. It is too powerful and too disruptive to be ignored. So that's one thing that I think everyone should understand, is that even if you don't know how to develop blockchain solutions, even if you don't know how to go and sit in front of a client and talk about blockchain, it's good for you to at least understand what blockchain is and what the benefits are, so that you can just be educated and understand this amazing innovation that we have the blessing to be witnessing in our modern day lives. Think about it like the internet. Early on, people didn't really think the internet was going to be that big of a deal. Even email, people thought, well, this is pretty cool. I guess you can send a message between two people without having to send mail. In the end, it's something we use every single day and we take for granted. And I think blockchain is a very similar construct to the internet, or the use of the internet for services like email. So definitely come back, subscribe to my videos. Let me know if there's anything you want to learn about, because I'm always happy to take your suggestions and teach based on what you guys are interested in.